I'm Dr. Jacob Nectarline. My background is in material science and metallurgy, and Elementum 3D is a company I started 7 years ago in the additive manufacturing industry. So what we do is we provide the metal ink for the additive manufacturing industry. And in general, we're looking at new materials or providing materials that we were told you can't print. It's not possible. So then we went after it and did it. We started doing that many years ago and have really been building on that. And if, as many of you may know, materials companies take a long time to get up and running because you need a lot of data. We now have that data, and we now have some really exciting applications going and really starting to dive into why additive, why use 3D printing, what are the advantages of 3D printing, where can you use it, where shouldn't you use it? So what makes this different? I mentioned earlier we can print materials that we can't. We have a unique technology we call reactive additive manufacturing that allows us to print materials that are otherwise unprintable. That essentially, if you try and print it, it suffers from the same problems that you have with welding. A lot of, say, high strength aluminums, high hardness steels, those sorts of materials that are difficult to weld are also difficult to print for the exact same reasons. We've solved that issue by essentially adding nucleation sites. So we can print these materials and they form and they produce properties that not only match that of the wrought materials that you can get through, say, CNC machining, but they in many cases beat it. And our materials that are designed for 3D printing that now have improved properties compared to, say, a cast, forged, or CNC machined part. In addition, we like to provide kind of a menu to our customers. When our customers are coming to look for a new material, you go to a CNC shop, you can choose from 60 different aluminum alloys alone. That's what we're looking to do, is be able to provide the right material for the right application. So aerospace heavy industry like additive manufacturing really goes after a lot of aerospace grade alloys, yet there weren't any. You couldn't produce, you couldn't print aerospace grade aluminums. So why 3D printing? What's the point? Why not just CNC machine? I did mention one thing of we can produce materials that you can't produce through CNC machining, which is exciting. But even if you were just matching the exact same properties, we have a 6061 that we sell a lot of, and there we have a lot of customers for. And the reasons they go after it are, I find, in about 4 different business cases. The first being lightweighting. Normally not a great business case. Sometimes you can tack that on to the other business cases, but alone, typically not where you want to be. Printing designs that are otherwise impossible. So being able to create channels and create different pathways or cooling that really hugs contours, that can't be done with traditional CNC machining. And that's a really important piece. Combining parts. There's one example of combining 20 parts into one. There's a new example that we've been looking into where they're looking at 900 different components that can be reduced to 20. Going from 900 components in a helicopter engine to 20 parts is a huge difference. Think about just the maintenance alone of, a guy who's out there on tarmac needs to inspect and look at an engine. Someone can keep 20 parts in their head. It takes a very special person to keep 900 different components in their head. So that, I think, is a huge important part. But if talking about Industry 4.0 today, the logistical improvements, I think, are really where there's going to be massive benefit of being able to produce parts on site or near where you need them, being able to source parts and email that, say, to the moon or Mars or the deserts of Afghanistan or wherever it is. To be able to email that design and print it where you need it is a huge difference in being able to create components and be able to supply those components without having giant warehouses everywhere of a million extra components. What sets us apart, again, is we've been looking into fatigue and looking at the material properties and looking at, well, how does our manufacturing process affect that? We are printer agnostic, so we work with a lot of the different printing companies out there, and then really dig into that and provide data so that we can do things like have flight hardware, have parts that are currently orbiting the planet right now. We have parts that are flying. We have parts that are in F1 racing vehicles. that are racing on the track today. All sorts of different applications where the materials was really the key. We have a team that's really experienced. I don't want to spend too much time on this. If you'd like to dive further into that, I'm happy to. I do want to highlight our partners here. So a lot of our customers and a lot of our suppliers, we work very closely with SLM and EOS. 3D Systems is just about to release our product as well. And a lot of our customers we like to work very closely with. So Lockheed Martin, Northrop Grumman, Ball Aerospace, many, many more. We have about 130 different active customers right now. We're moving into a new facility here very soon. And we just finished a round of funding we're nearly finished with that round of funding. We've completed about $15 million, and we're looking to finish up that last 5 here for this round where we are today. So if there's any questions, I'd be happy to take them, and we can kind of go from there.
Awesome. Thank you so much, Jacob. Open up the floor for questions. We have a question from David Mendelson.
Thank you very much, Jacob. That was really interesting. Are you a part of any steady production programs, or are your products mostly in R&D type applications?
We have a couple of production programs. A couple of them are in the defense departments. We can't go into them too far, but we do have a production component where we have our material in about 20 printers running components all day, every day for racing vehicles.
Thank you. And a second question for your ideal application is that, I know you mentioned engine parts a couple times. Are you targeting engine applications or anywhere on the airframe?
All sorts of different portions of the airframe. RF applications are pretty high on there. Any cooling applications or actuators. Actuators tend to be places where you can take a lot of components and reduce them to fewer. Nickel, places where you need high-end materials like nickel superalloys for corrosion resistance or high temperature performance, or other places where you need high thermal conductivity, like in data centers, they're looking to cool their data chips. So we're working with some of the big names there too in the data center world.
Great, thank you.
Yeah. Awesome. Jane, do you want to ask the next question?
I was just wondering, it sounds like you're doing some aluminum composites and so on. What other types of materials are you able to do? And are there not other companies that are making these types of composite material, additive materials? And have you partnered with companies like Desktop Metal to consider using it with them?
Yeah, so we've done quite a bit of work with a lot of different companies on a lot of different materials. Aluminums were where we started, so we have the most data for the aluminums. And again, like I say, people have been trying to solve that high strength aluminum welding problem for 50 years and hadn't solved it before we did. So that there's not a lot of competition in that particular space because it was a difficult problem to solve. But certainly we've looked at all sorts of other materials that we're now getting into some really exciting conversations as far as high thermal conductivity coppers. Some nickel superalloys, very high temperature nickel superalloys that are hard to print as well. And then refractory metals like tantalum and others for really niche applications.
Awesome. Last question from Corey.
Hi, yes, sir. So the question I've got is with regards to aviation. Honestly, it's been a hard problem to do anything with 3D printing additive manufacturing because the results are not always the same. What is your quality control, quality assurance process to ensure that you're meeting aviation rigor required for the various aluminums that you're utilizing? Over.
So one of the things that our customers like the best about our material is the consistency. The process window is really wide on it because we have this kind of distributed nucleation site material through the material. It means that you can be running at a power level that's really wrong, or you can have something go very wrong with the process and the material property comes out very similar. So not only are we ISO 9001 and we're looking to be AS 9100, not only have we gone that far, but the other advantage is that our material just opens that window up for someone who, if there is a mistake or something does go wrong, it provides that kind of room for the material will still perform as intended. And so that certainly was a concern in the additive manufacturing world. And it's one of the reasons that our customers like Lockheed and Northrop are so excited about our material, is because that process window is so wide, it reduces that concern.
Okay. Have you had any issues with airworthiness within the government? You know, you have airworthiness certification requirements. Have you had any issues getting it through any of those boards?
It's very expensive. So we currently sit on the committee to kind of work through the MMPDS requirements, and we hope that the MMPDS will have a list out for here's what the full qualifications are, so that you don't have to qualify on each individual component. So that's coming very soon. But yeah, I mean, it's a concern, and it's always tends to be today a conversation. I would say maybe 2 years ago, it's been a big conversation where it takes a long time. You've got to convince them, you've got to provide all the data, here's everything. That conversation is becoming easier and easier because we already have applications that it's been done in. So now that we have applications we can point to, we can say, not only do we have the data, but here's this other application that's going quite well. And so that's been really beneficial as far as why we're ramping up now and why things are starting to take off now, even though it started 7 years ago.